The topic is understanding the architecture of Kubernetes and its components. Here is the diagram and the architecture of the Kubernetes. Kubernetes splits its responsibilities into two distinct planes, that is control plane and data plane. Data plane is also known as worker nodes. Nodes simply are virtual machines or physical servers. For example, if you are running a Docker container, you would be running it in a virtual machine, that is an EC2 instance that itself is a physical server or a virtual machine. So in Kubernetes, it is called as nodes or node if it is single. So there is a concept in Kubernetes that is worker nodes, which is also known as data plane. Worker node performs the task, and there is the concept that is control plane, which is responsible for controlling the data plane or the worker nodes. So in control plane, these components make global decisions. So for control plane components make global decisions about the cluster. Simply, cluster is a collection of nodes. Nodes simply is a collection of virtual machines. A single node is a single virtual machine. So collection of these nodes or virtual machines is known as cluster in Kubernetes. So control plane is responsible for making the global decisions about the cluster. For example, scheduling and detecting or responding to the cluster events. So all decisions are made by the control plane, and worker nodes operate on those decisions controlled by the control plane. In Docker, we had the smallest unit, that was container. In Kubernetes, we have the smallest unit, that is pod. Pod is not exactly container, but it is a wrapper around the container. So that was a simple split between the Kubernetes architecture, which has control plane and the data plane. Data plane also known as the worker node. And we can observe in this architecture, control plane has API server, etcd, scheduler, kube control manager, and cloud control manager. These are the components in the control plane of the Kubernetes architecture. And in the data plane, we can observe that there exists container runtime, kubectl, and Kube Proxy as a components. Now let's understand them deeply. First, the control plane or the master. It has a component that is Kube API server. The API server is the only way into the cluster. If we want to tell Kubernetes to do something, we send a request to the API server. It is the public face of the system. So every request is communicated to Kubernetes via Kube API server or API server. Simply, API server is responsible for the communication of Kubernetes and its components to the external world, or communication of request and it performing the task. What it does, it receives our commands like run 3 pods. It checks if we have permissions to make that request, that is authentication, and it ensures that the request is valid, that is the validation. So why it matters? No other component talks to each other directly. The scheduler wants to talk to the node, it goes to the API server. It is a central hub that keeps everything organized and secure. So as I mentioned, no other component talks to each other. It needs API server to communicate. If the scheduler wants to talk to the node, it goes to the API server. So API server is the central hub that keeps everything organized and secure. Now etcd, Kubernetes is stateless, meaning the component themselves don't remember anything. All the memory lives in etcd. So Kubernetes is stateless, so it doesn't remember anything themselves. It needs etcd, or it has the memory, that is etcd. What it does, it is a specialized database that stores the entire state of our cluster. It records exactly how many pods are running, which nodes they are on, and what their IP addresses are. So etcd is like the specialized database that stores entire state of our cluster. It records exactly how many pods are running in our cluster. It records which nodes they are on in the cluster and what are their IP addresses inside the cluster. So it is a specialized database that is responsible for managing the storage of our cluster. So Kubernetes itself doesn't have the components or anything that is responsible for storage. So it needs etcd to manage that. Why it matters? If the API server is the receptionist, etcd is the massive filing cabinet behind. If the entire control plane crashes and restarts, it looks at etcd to remember what it was doing. If we lose etcd, we lose our entire cluster. So you can remember this point. If entire control plane, that includes all components in the control plane, crashes and it restarts, so it would look at etcd that manages or acts as a specialized database to remember what it was doing. So in short, if we lose etcd, we lose our entire cluster. Now, Kube scheduler. When we ask for a new pod that is not exactly a container but a wrapper over a container, the API server doesn't know where to put it. It asks the scheduler. We know that Kubernetes has a concept that says that is auto healing and auto scheduling and auto scaling. In order to have those features run properly, there must be a concept that is scheduler, that is responsible for scheduling and assigning smallest units, that is pods, in the right position, in the right manner, and then in the right time. So Kube scheduler ensures that the hardware is used efficiently. So what it does, it looks at our available worker nodes, that is the servers, and checks their health and capacity. It asks which server has enough RAM and CPU to fit this new pod. So we know that the worker nodes or the nodes are like the virtual machines or servers. So Kube scheduler checks the health and capacity of it, and it simply checks which server has enough RAM and CPU to fit the new pod. Why it matters? Without the scheduler, our pod would just sit in the pending state forever. It ensures our hardware is used efficiently, not putting all the heavy apps on one server while others sit empty. Now, Kube controller manager. In Kubernetes, we don't start an app, we declare a state. Example, I want 5 copies of this app running. The controller manager is the person who makes sure that the reality matches our wish. So in Kubernetes, there is a concept of controllers. What is a controller? Controller is a concept where there are certain controllers which has certain responsibilities. For example, if we need replicas or we want 5 copies or 10 copies of the pod running, so there must be a concept that makes sure the replicas are running. So the controller has controllers, that is replica set, or something that manages the replicas of the application, and there are other controller as well which has some other responsibilities to do. Simply, there are many controllers that serve a purpose for our pods, nodes or cluster. So one of them is to perform the replicas of the pods, that is a controller. To manage these controllers that serve different purposes for our pod, cluster or nodes, there is a concept of Kube controller manager that manages these controllers. What it does, it runs control loops that constantly watches the cluster. If we ask for 5 copies but a server crashes and now only 4 are running, the controller manager notices the gap and tells the API server, hey, we are missing one. Tell the scheduler to find a new home for it. So again, we got a concept of API server here. So everything is communicated through the API server. So Kube control manager notices only 4 are running, but we ask for 5. So it asks the API server to fill this gap or accept this request and to find a new home or new position for that pod. Why it matters? This is what makes Kubernetes self-healing. It is a component that fixes problems automatically without we having to wake up at 3 a.m. Cloud controller manager. Modern Kubernetes often runs on clouds like AWS, Google Cloud or Azure. These clouds have their own features like load balancer or storage disk that aren't part of the Kubernetes itself. What it does, it acts as a translator between Kubernetes and the cloud provider. If our app needs a public IP address, this component talks to the AWS or Google and says, please give this cluster a real world load balancer. So Kubernetes doesn't have load balancing on itself. It has a concept of load balancer or managing disk, but it needs a cloud provider to fulfill those requests. And there are many cloud providers. Each cloud provider has their own features as their own names for the same features they offer. For example, load balancer or storage disk, they have different names and different different syntax or different, simply they are different cloud providers, so they are not same. So Kubernetes must be having a component that respect all these cloud providers and support them to fulfill their request or fulfill what they offer to us, like load balancer, and these services. So cloud controller manager acts as a translator between Kubernetes and that cloud provider to fulfill the request. Why it matters? It keeps the core Kubernetes code clean. By separating this out, Kubernetes can run exactly the same way on a laptop as it does on a massive cloud provider. So the summary of the flow would be: we tell the API server, I want 2 pizza. The API server writes order 2 pizzas into the etcd ledger, so it keeps the data of it. The controller manager sees the ledger, says 2 but sees 0 in the kitchen. It tells the API server to create them. The scheduler looks at the available kitchens, that is the nodes, and picks the one with the best oven. The kubelet, the cook of the kitchen, sees the order and starts cooking. So that was about the control plane or the master node. Now let's understand the worker node or the data plane. These are the boots on the ground that do the heavy lifting. It has a component that is Kubelet. This is the node agent. It is the most important component on the worker node. It receives pod specs or the instructions from the API server and ensures the containers described in those specifications are running and healthy. If a container crashes, the kubelet restarts it. We know that pod is the smallest unit in the Kubernetes. So kubelet is a concept or is a component in the worker node that makes sure the health of that pod and makes sure the pod is up and running. It communicates with the API server to fulfill those demands to make sure it is always healthy and running as per our needs. The container runtime CRI. To run containers, Kubernetes needs a motor. We know that the smallest unit in Kubernetes is pods. So simply pods are the wrapper over the container. So there is still the concept of containers in Kubernetes, which means containers are still present inside the pod simply. So if there is a concept of containers, there must be a concept of container runtime. Container runtime makes sure containers are running. If there is no container runtime specified for a container would not run. So Docker has only Docker shim as a container runtime that talks to the Docker to fulfill container request. However, Kubernetes doesn't only rely on Docker shim. It can use Docker shim, but it can also use the competitors of the Docker shim, that is Containerd or Creo. So the old way would be Kubernetes use Docker shim to the Docker. Modern way is Kubernetes uses container runtime interface CRI. It now talks directly to runtimes like Containerd or Creo. Docker is no longer required to run a Kubernetes cluster. It can also use other providers as well. Now Kube Proxy. This is the network supervisor. It maintains network rules on nodes. These rules allow network communication to our pods from inside or outside of our cluster. So in order to have certain features or certain benefits of Kubernetes, that is auto scaling, auto healing, etc., there must be a concept of strong network communication. Simply, Kubeproxy is a concept or a component in the worker node of Kubernetes that takes care of the IP addresses of the pod and load balancing of the pod. Load balancing means load must be balanced accordingly so each pod is healthy and doesn't get affected with the performance of other pods. So Kubeproxy makes sure of the IP addresses and load balancing of the pods. Now the smallest unit, the pod. While Docker's smallest unit is container, the smallest unit in Kubernetes is the pod. Important distinction: we do not deploy a container in Kubernetes. We deploy a pod. A pod is a wrapper that can hold one or more containers, usually just one, that share the same network IP and storage volumes. So the workflow would be Kubernetes works on a declarative model. We don't tell it start this, we tell it this is what I want the world to look like. So the first would be the request user API server. We send a YAML file to the API server saying I want 3 replicas of my web app persistence. API server etcd. The API server saves this desired state into the etcd, that is like the standardized database scheduler. API server. The scheduler notices new pods are needed. It looks at the worker nodes, finds one with enough RAM and tells the API server put these on node A. Execution. Kubelet. Container runtime. The kubelet on node A sees the assignment. It tells the container runtime examine Containerd to pull the image and start the container. Monitoring. Controller manager. API server. The controller manager constantly checks, does etcd say 3? Are there 3 running? If one dies, it starts the cycle again to fix that. So that was the workflow of it, and that is it for the video today. Thanks so much for watching. Have a great day. Bye.